How about this one? 1.261.
Do I sense a text?
How about this one?
2.8.
Try again. 27.60. Yes. This is millimeters. Since this says millimeters on here, you've got to read this as 20, not 2. How about this one? 4.887 looks good to me. We're not quite to 0 yet, so we haven't quite made it to the 9. How about this one?
1.609.
Yes, it is. 1.609 is correct, sir. Oh, this one. 62.48. That one. Why are you staring at Zach?
Well, I was going to give him a shot. I got 3.653.
So it was 3.653. Yeah, those will never be on a quiz. Those, I just wanted to show you those so you knew that they existed. 1.142, perfect.
3.437.
9.12 actually. We're right at the 9 line here. We've just passed 0, which means we must have just passed the 9. How about that one?
86.81.
Perfect. That one? 27.60. That one? 0.814 is perfect. That one? Perfect. I think you've got those down. In fact, let's do this. That's Spanish or Latin for metric caliper. What's that saying?
46.44.
How about that one? That one?
44.23.
How about there? 34.10. How about there?
26.98.
Perfect. 26.98. Hasn't made it to 0 yet, so we're not to the 27 yet. How about that one?
10.93.
Try again. 15. 15.93. There. How about that one?
35.04.
35.04. Good deal. No. Well, I can't see that until I lift it up. I can't see that either. But one thing I want to show you, you know, this is not U.S. made. See there where that decimal point should be? It's a comma. A lot of European countries use a comma in place of the decimal point. They want to be different. They can't handle being like the big dogs. How about here? What's this one reading?
16.49.
I was going to say you could just read it down there. What's that one read? 1.919. How do we know that this one's in inches, even if we can't read this up here? Yeah, two different number scales here. What's that one read? 1.520. How about that one? 0.702. How about that one? 1.041. And that one? Yes. And remember, we had these bundles of fun. Vernier. First of all, metric or standard? Standard. What do we read on the main scale here? We read it where the 0 is, don't we? So it's 1 whole inch. And then this is 0.6. But then this is 0.625, 650, 675. Does that make sense? There's these, between the 0.6 and the 0.7, there's 4 divisions. So this is 25, 50, 75 thousandths. You look confused there, Nate.
I'm just trying to think of how we're going to be accurate on the test.
How are you going to keep them all straight?
Yeah, well, I'm just being able to give an exact answer because there's a lot of, like it's 1.692 right there.
Yeah.
But
well, let's read it.
75 through that is 25 thousandths. That's a lot of.
Well, you got 1.675, right?
Right.
Well, to get the rest of it, you come up here on the vernier scale. Which one of these lines on the vernier scale lines up with one of these?
15.
Looks like the 17 lines up, right? The 15 lines up, 16, 17. I would probably say the 16 myself, because the 15, 16, and 17 all line up. So I would probably take the 16. So 1.675 plus 16,000 would be 1.691. They're saying 1.692. Well, I would disagree with them slightly on that.
Okay, so you'll give us a little bit of leeway on our answers based on.
If I can see how you would get that answer based off of it, I'll give it. I'll let you have it. So how about this one? Yep, so it's past the 5, 2550, so it's 0.550 plus
17?
I would say 16, 17, I'd say the 17. So 0.567, 0.550 plus 17 is 567, so 0.567. They're saying 0.568, but they're wrong. How's about this one? So it's 2.2. We are past the 25 mark. So 2.225. And then up here, what lines up would be, I'd say the 8, 9, and 10, so I'd take the 9. So it's 2.225 plus 9 thousandths is 2.234. 25, well, this is the 2. This is the 0.2. Then this is 25, 50, 75. It's past the 25. These have quarter marks between the tenths. And then this one. This is the metric vernier caliper. So this is 45, 6, 7, 8. 48 is between 48 and 49, right? Then whatever we read off of here,
I'd say the 7.
this is 70. This is actually 70. 72, 74, 76, 78, 80. So it looks like the 68, the 70, and the 72 all line up. They're saying 72, but I would say 70. So I'd say 48.70. Yeah, it makes your eyes go buggy, doesn't it?
Yeah.
So this is 25, 6, 7, 8, 28 point. I'd say 48 myself. Yeah, from like 44, 46, 48, 50, 52 all line up. So I would take 48. It seems to be right in the middle.
Are you sure we're not reading Braille?
Well, remember, like I said, when I read these, I've got it in front of me. I will actually tip it like this, so I'm looking down the lines. And when you're looking like this, then it's easy to see if there's any slight jog in them. Looking at it straight on like this, it is really tough to see. And especially on a computer simulator where this is limited by the pixels in the computer screen. So you got to remember that those are actually jumping pixel at a time. So if they're less than a pixel off, they're going to line up on the computer screen. This being a smaller screen might not have the resolution to distinguish between them. So our next step, we're going to talk about micrometers. Don't let me forget, Zach. I'll give you a packet with the calipers on it. These guys got a packet of calipers to read. A micrometer. I actually have some of those in here that we'll look at. So a micrometer looks kind of like a really delicate C-clamp like this. This is a micrometer. First thing on a micrometer, now ones we see, all you're going to be seeing on ours is this portion of it right here. You're not going to see the actual jaws of the micrometer. But you'll see right here it's printed 0.001 inches. Then above it it's 0 to 1. A micrometer, each turn of the thread is 25 thousandths of an inch. So that means I have to go 1 inch, I have to turn this 40 rotations. That's a ways, right? For 1 inch. So they don't make, I mean, I've seen them where they make micrometers that go 2 or 3 inches, but they don't do it very often because that's a lot of turning. So more often than not, what they'll do, this measures things from 0 to 1 inch in size. If I need something bigger, they have what's called a 1 to 2 inch. So all the way open, it's at 1 inch. So all the way closed, it's at 1 inch. So it doesn't close tighter than 1 inch. So it can't measure anything smaller than 1 inch. Then it opens up to 2 inches. Then they have a 2 to 3 micrometer. So again, all the way closed is at 2 inches and it opens up to 3. Well, because they want the jaws. The nice thing about these is the caliper is not as sensitive. You've got that little slip wheel, the thumb wheel. Here, if I want to make sure I'm tightening it down without over tightening, because I mean, if I grab onto this, I mean, I can mar metal and I can get an extra 4 or 5 thousandths out of it or more. In fact, I could bend the jaws of this if I have to. Used to have a couple in here that I scrapped that people had over tightened and bent the jaws on them. This, if I want to get it to a certain preset tightness, there's a clutch on it. So I'm turning it in and it slips. Yeah, it won't keep going. It only gets as tight as the spring on that clutch allows. If it's something that goes into a height gauge, you're talking about a surface gauge. Yeah. If it fits into that, then you can do it, yes. These do have to be zeroed out when you put them down tight. This one is not zeroed out right now. nowhere near zeroed out right now. So what you want to do is you want to line up the 0 on them with the axis on the barrel. So you have this little wrench that comes with. You probably can't see it real well. Might be able to see it better if I hold it up like this. Actually put it on there, you'll turn the whole barrel of the thing to line up the 0 with the 0. Like that. I will pass these around so you guys can mess with them a little bit in just a second. So we have two main parts. We have the thimble, which is the little part that spins. We have the barrel, the part that stays stationary. Remember, the big C thing is over here. So this would be connected into the jaws. And this is the part that's coming out as you screw it in and out.
Are you sure you weren't an artist at one point?
I'm pretty sure I'm not an artist yet. So anyway, you read the barrel first here, the main scale first. And that main scale, remember, how many whole inches are there here? 0 whole inches, 0 to 1. So this is always 0 whole inches. Unless it states that it's a 1 to 2 or a 2 to 3 or a 3 to 4, your whole inches is always 0. How many tenths do we have? We are past the 3/10, so that's 0.3. Now, just like the vernier caliper, we have quarter marks. This is 25, 50, 75. So we're past the 25. Have we made it to the 50 yet? No, we have not. So that's 0.350. That's my reading off the barrel. It's 0.350. Now on the thimble, it's 15, right? That's 15,000. So 0.3. Oops, I don't know why I wrote down 350. We didn't make it to 350. It's 325, right? 325. We didn't make it to the 50 yet. So this is 340. Who that's reading? We'll talk about metric in a little bit. Let's practice on the standard ones here. Make these bigger so you can see them a bit better. Well, 0.225, right? And plus 15.240 inches. How's about this one? 0.4. Have we made it to the 25? In fact, we're at 0 here. We've exactly made it to the 25, right? How's about this one? Have we made it to the 0.8 yet? We're exactly at the 0.8 because we're at 0 here. This one. We've got the 0.9, 25, 50, 75, so 0.975. And yes, that is 5 thousandths. So 0.980. How about this one? There it is. 0.599. This is 24 here. We have not quite made it back to the 0, so we can't quite have made it to the 6 yet. How about this one? .625. This is 0.6, and that's the 25 mark. And then it is 1 on the thimble, so 0.001. So 0.626 inches. This one. Nine. So 0.434. Yeah. See the 5 here, so it's going to be 6, 7, 8, 9. This one. Why'd I put down 2.5 instead of 50? Yeah, this is 21, this is 22, 23, 24, 25 puts us back at 0. So not quite to 0 yet, so we have not quite made it to the 750. Plus 22, so 0.747. Now this one here, if you look over at the jaw, on the jaw it says what's that mean? 2 to 3 inch caliper, which means it starts out with how many whole inches? 2 whole inches. So 2.875, yes, plus. So it's 2.898. This one? Assuming this is still a 2 to 3? Okay. 2. There's 13 on the thimble, so 2.338. And then we go to inside micrometers, depth gauges. These only have a 1/2 inch of travel on the barrel. This is a 3 to 4 inch extension, which means we're starting out at 3 whole inches. What do we have here? Point what? 225 plus 20. So 3.245. Make sense? What looks different about this one, other than the fact that this is in a different location? Do you see the difference yet? There's actually a piece in there, isn't there? This is still 3 to 4, so it means it starts at 3 inches. Remember I said there's only a 1/2 inch of travel here? So that's a 1/2 inch extension there. So this is 3.5 starting out. Then we've got to add the barrel, which is point what? 3.25, and then the thimble, 0.012. So 738, so 3.837 inches. Sound like fun? You got to see it there. I mean, if you were reading one, you would have to put the 1/2 inch extension on it so you'd know it's there. How about here? Yep, exactly, 24. 2 whole inches, 0.350, and then 24 here. So 2.374 inches. How's about this one?
3.5
plus 1.125 plus another 10. So 3.635 inches. You can see these, because there's 3 stages. You've got this extension gives us a 3. This gives us another 1/2 inch. Then you've got the barrel. Then you've got the thimble. There's 4 levels of reading here. Really hard to read these without paper and pencil to write it down as you go. I would have a hard time doing these without being able to jot it down. What's that? Yeah. Yeah, you can do 3.5625, 35, 3.6235. I mean, you can read it, but it's, if you're having an off day. So what's this one read? 4.999. This is metric. Since this is not labeled in ones anymore, it's labeled in fives. This is metric. This is millimeters here. This is 15, 16, 17, 18, 19, 20 millimeters. These are the half marks. So this is 20, 20 and 1/2, 21. It is past the 21 because we've just passed 0. And this is 5 here. Well, this reads all the way up to 50, so that'd be 05. Does that make sense? So this is 15, 16, 17, 18, 19.5. And then over here it is 0.45, so 19.95 millimeters. This one. .5, 6, 7, 8.5, and that's 0 there, so it's just 8.5. Right on, yeah. How about this one? Oh, wait a second. That can't be 8.5. What's that one got to be? That's wrong. That's not 8.5. We've made it back to 0 here, and we're definitely past the 8.5. We're right on the 9 there. That has to be right on the 9. That would be 3. 14.03. That's it. There's nothing to add to it. Yep.
17.5 plus 0.35 is
17.85 is exactly correct. Nate gets the gold star for the day.
Hey, participation awards are worth it. Shows you're a good try.
In your book, page 183, exercise 4.4a. Page 186, exercise 4.4b. Both of those are going to be 1 through 20.
that 4.4?
4.4a and 4.4b, yep.